Hello my scholars, you are welcome to my school YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2000. So relax, do not go anywhere and we will be right back. You are welcome back to my school YouTube channel. In today's video, we shall be solving question 26 to 49. So let's begin with question 26. In a thermonuclear reaction, the total initial mass is 5.02 times 10 raised to power minus 27 kg, and the total final mass is 5.01 times 10 raised to power minus 27 kg. The energy released in the process is, so we are asked to take C, which is speed, to be equals to 3.0 times 10 raised to power 8 meter per second. So let's move to the board to provide answer to this question. So to solve this question, we are going to be using Einstein's energy and mass relationship. E is equals to change in mc squared. Okay, so in the question we are given initial mass to be equals to 5.02 times 10 raised to power minus 27 kg, and we are given final mass to be equals to, okay, mi, then mf for final mass to be equals to 5.01 times 10 raised to power minus 27 kg. Okay, and we are asked to take speed to be equals to 3.0 times 10 raised to power 8 meter per second. Okay, so those are the parameters that are given to us in the question. So let us substitute. Of course, remember that delta S stands for change. Okay, so change in mass will be 5. So E will be equals to change in mass, which is 5.02 times 10 raised to power minus 27, then minus 5.01 times 10 raised to power minus 27. Okay, times, let's put this in bracket, times in bracket 3.0 times 10 raised to power 8 in bracket square. Okay, so if we subtract here, we'll be having, if we subtract these two, we'll be having 0.01 times 10 raised to power minus 27, then times, so we are going to raise this, that will give us 9, then times, of course we multiply the two powers, that will give us 16. So when we multiply these two values together, we'll be having 9.0 times 10 raised to power minus 13 joules. Okay, so let's return back to the screen to pick the correct option to this question. So from our calculation, we got 9.0 times 10 raised to power minus 13 joule, and that agrees with option A. Okay, so that makes option A the correct answer to this question. Question 27. A gas will serve as an electrical conductor under A, reduced pressure and high current, B, increased magnetic field, C, reduced pressure and reduced potential, D, exposure to visible light. So a gas will serve as an electrical conductor under reduced pressure and high voltage. So let's go through the option and see the one that is closest or that agrees with our explanation. A, we have reduced pressure and high current. B, we have increased magnetic field, which is not close to our explanation. C, reduced pressure and reduced potential, which is close, but here they use the word reduced instead of high. Okay, then D, we have exposure to visible light, which is not even close to the answer. So the closest option is option A, reduced pressure and high voltage, and the reason for that is because according to Ohm's law, voltage is directly proportional to current. So we can say that high voltage presupposes high current. Okay, so that makes option A the correct answer to this question. Question 28. An electric generator with a power output of 3.0 kilowatts at a voltage of 1.5 kilovolts distributes power along cables of resistance 20 ohms. The power loss in the cables is, so let's return to the board to provide answer to this question. So first of all, power loss is given as I square R, okay? But in this question, we are not giving current. These are the parameters that are given to us in the question. So first of all, we have to calculate for current. But remember that power is equals to IV. Okay, so from here, we can calculate to get the value of current. And in this question, we will be given power to be equals to 3.0 kilowatts, which we have to convert to watts, which will be equals to 3,000. Okay, so kilo here stands for 1,000. So 3 kilowatts means 3 times 10 to give us 3000 watts. Okay, so here we're also giving volts in kilovolts, so we convert to volts, and that will be 1500. Okay, 1500 volts. Then our resistor was given to us in ohm. So from there we can get the value of current from this equation. So we put our 3000 here, and we have our I times, which is current, times 1500. So we can make the current the subject of formula by dividing both sides by 1500. So here we'll be having 3000 divided by 1500, and that will be equals to 2 ampere. Okay, so now that I've calculated for our current, we can now calculate for the power loss. Okay, so power loss is equals to our current 2 squared, then times the resistance, which is given to us, will be equals to 20. So this will be equals to 4 times 20, and if we multiply 4 by 20, we'll be having 80 watts. So the power loss in the cables is equals to 80 watts. So let's return back to the screen to pick the correct answer to our question, and that is option A, 80 watts. Question 29. If the frequency of an emitted X-ray is 1.6 times 10 raised to power 16 Hz, the accelerating potential is, so we are asked to take E to be equals to 1.6 times 10 raised to power 19 coulomb, H to be equals to 6.63 times 10 raised to power minus 34 joule second. So let's move to the board to provide answer to this question. So to calculate this question, we are going to simply use the energy of the emitted X-ray. So the energy of the emitted X-ray, EV, is equals to HF. Okay, and we are where E stands for the accelerating potential. So we can make E here the subject of formula, so that the accelerating potential V is equals to HF divided by E. Okay, so we just put in the values that are given to us. So we are asked to take H to be equals to 6.63 times 10 raised to power minus 34, then times the frequency that is given to us to be 1.6 times 10 raised to power 16 divided by E, which is 1.6 times 10 raised to power 19. Okay, so if we divide the numerator by the denominator, we'll be having 66.3 volts. Okay, let's return back to the screen to pick the correct option to this question. Okay, so that leaves us with option C, 66.3 volts. Question 30. If the fraction of the atoms of a radioactive material left after 120 years is 1/64, what is the half-life of the material? So let's move to the board to provide answer to this question. So we use this formula. N is equals to N naught bracket open 1/2 raised to power T divided by the half-life, which is T, then subscript half. Okay, where N stands for the original mass of the material, while this stands for what is left, right? So if we make this the subject of, if we make 1/2 raised to power T over the half-life the subject of formula, we'll be having N over N naught to be equals to 1/2 raised to power T over the half-life. Okay, so here is the fraction of what is left, and we are told that it is 1/64. So here will be 1/64 is equals to 1/2 raised to power, and our T here is equals to 120. Okay, raised to power 120 all over the half-life. Okay, now in this question we are calculating for half-life, so we can write this in index form, so that we'll be having 1/2 raised to power 6 is equals to 1/2, then 120 over the half-life, right? So this takes this out, so that we'll be having 6 is equals to 120 all over half-life, right? Now since we are looking for half-life, we can just switch the position of 6 and the half-life, so that the half-life becomes 120 divided by 6, and that will be equals to 120 divided by 6, and that will be equals to 20 years. Okay, so let's return back to the board to pick the correct answer to this question. Okay, so from our calculation, the half-life of the material is equals to 20 years. So that makes option B the correct answer to this question. Question 31. A certain radioactive source emits radiations that were found to be deflected by both magnetic and electric fields. The radiations are A, beta rays, B, gamma rays, C, X rays, D, ultraviolet rays. So A, we have beta rays. So beta rays are high energy and fast moving electrons or positrons They are positively or negatively charged, and they are deflected by both magnetic and electric field because of their mass compared to that of alpha particles. Then B are high energy electromagnetic waves and are neutral, meaning that they are not deflected by both magnetic and electric field. X-rays are electromagnetic waves of short wavelengths. They are produced when a fast-moving electron strikes a mass of heavy atoms such as those of metals. Then D, we have ultraviolet rays. So ultraviolet rays, they are electromagnetic wave, okay, of wavelength of the order of 10 raised to power 8 meter. So when they fall on the skin, they causes skin burn. So the answer to this question is beta ray. So beta ray are the radiations that were found to be deflected by magnetic and electric field. So that makes option A the answer to this question. Question 32. A 2 Henry inductor has negligible resistance and is connected to a 5/pi Hz AC supply. The reactance of the inductor is, so let's return to the boards to provide answer to this question. So inductive reactance SL is equals to 2 pi Fl, where L here stands for inductor. Okay, so according to the values that are given to us, we have a frequency to be equals to 50 all over pi Hz, and we have the inductor L to be equals to 2 Henry. So we substitute this into our formula so that inductive reactance is equals to 2 times pi times 50 over pi times 2. So pi, we cancel out pi, so that we'll be having 2 times 50 times 2, that will be equals to 200 ohms. Okay, so let's return back to the screen to pick the correct answer to this question. So the correct answer to this question is option A, 200 ohms. Question 33. A cell of internal resistance 1 ohm supplies current to an external resistor of 3 ohms. The efficiency of the cell is, so let's return back to the board to provide answer to this question. So we know that efficiency is equals to power output all over power input times 100 over 1, or times 100%. So in this case, our power output is equals to arrow, while our power input is arrow plus small arrow times 100. Okay, so our arrow, according to the question, arrow here stands for external resistor. Okay, and that is given to us to be equals to 3 ohm. So 3 ohm plus, and the internal resistor was given to us to be equals to 1. This will be multiplied by 100. So here we'll be having 3 over 4 times 100 over 1. So 4 here is 1, 4 here is 25. So 3 times 25 equals to 75%. Okay, so the efficiency of the cell is 75%. So let's return back to the screen to pick the correct option to this question, and that is option D, 75%. Question 34. A conductor of length 2 meter carries a current of 0.8 ampere while kept in a magnetic field of magnetic flux density 0.5 Tesla. The maximum force acting on it is, so let's return back to the board to solve the problem to this question. So the force acting on the conductor is given as F is equals to ILB sine theta. Okay, but for the force to be maximum, then sine theta must be equals to 90 degrees. So sine theta is equals to 1. Okay, so that F now becomes 1 LB. Okay, so in this question we are told that I, which is current, is equals to 0.8, and the length of the conductor is 2, then times the magnetic flux density, which is 0.5. Okay, so if we multiply, we'll be having, okay, so this is 8 over 10 times 2 times 5 over 10. Okay, so if we multiply through, we'll be, okay, this 10 is going to take out this 2, so that at the end of the day, we'll be having 0.8 Newton as the maximum force acting on the conductor. Okay, so let's return back to the screen to pick the correct answer to that question, which is option B, 0.8 Newton. Do you know that you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and that will take you to Myschool website. There you have to download Myschool mobile app for your Android devices and Myschool software for your laptops and computer. Please go ahead and start practicing. Moving on to question 35. Light of energy 5 eV falls on a meter of work function 3 eV and electrons are liberated. The stopping potential is, so let's move to the board to provide answer to this question. So for a photo-emitted electron, EV is equals to maximum kinetic energy of the emitted electron. Okay, but the maximum kinetic energy is given as the energy of incident radiation minus the work function, Fw. Okay, so in this question, we are given the energy of the emitted electron to be equals to 5 eV and that of the work function to be equals to 3 eV. Now remember that the V stands for the stopping potential. Okay, so we have EV to be equals to, then we'll be having EV to be equals to 2 EV. Okay, so we can make V the subject of formula. So V becomes 2 EV divided by E. So E will cancel out E so that the stopping potential V is equals to 2 volts. Okay, so let's return back to the screen to pick the correct answer to this question. So from our calculation, we got 2.0 volts. So that agrees with option B. So that makes option B the correct answer to this question. I believe you are enjoying this content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 36. The velocity y of a particle in a time t is given by the equation y is equal to 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. So let's move to the board to find the instantaneous acceleration. Okay, so the instantaneous acceleration A is given as the V all over the t. Okay, so in this question, V is given to us to be equals to 10 plus 2t squared, right? But the t was represented with letter y. So that our A is equals to the y dt, and that will be equals to, so we differentiate this, and that will be equals to 4t. So to get our instantaneous acceleration, in place of this t, we replace it with 5, okay, according to what is given to us, so that our instantaneous acceleration A is now equals to 4 times 5, and that is equals to 20 meter per second squared. So let's return back to the screen to pick the correct answer to this question. Okay, so from our calculation, we got 20 meter per second squared, and that makes option B the answer to this question. Question 37. A simple pendulum has a period of 7.0 seconds when the length is shortened by 1.5 meter. Each period is 8.5 seconds. Calculate the original length of the pendulum. So let's move to the board to solve this question. So this is what is given to us in this question, the parameters that are given to us. So we are asked to calculate the original length of the pendulum when the length is shortened by 1.5. Okay, so this is the original length. So we call the original length T1 and we say let it be L. So we are told that L2, which is equal to the original length is shortened, so here will be L minus 1.5, right? But remember that the period of a pendulum T is given as 2 pi, then bracket open L over G, right? So all these force to become constant. Okay, so we'll keep all this to be constant so that T is equals to K root L, right? So that if we make K the subject of formula, we'll be having T to be equals to root L. Right, and the other one, so if we call this equation 1, then we are going to perform another one again, which we will also call equation 1. So we now equate the two k's, so that here we'll be having T1 to be equals to T2 all over root L minus 1.5. Okay, so let's impute the parameters that are given to us. So there we'll be having 17 over root L is equals to 8.5 over root L minus 1.5. Okay, so we can rewrite this to be equals to 17 divided by 8.5 to be equals to root L over root L minus 1.5. So if we divide this, that will give us 2 equals to root L over root L minus 1.5. So we take the square of both sides in order to kill off the square root here. So that we'll be having 4 to be equals to L all over L minus 1.5. Okay, so since we are calculating for L, we cross multiply. So that we'll be having L to be equals to 4L minus 6. Right, then we'll collect like terms. So if we collect like terms, we just move this to this as well. We'll be having minus 3L is equals to minus C. So we divide both sides by minus 3. Okay, so that L is equals to minus 6 divided by minus 3. So minus will cancel minus 3L1, 3L2. So that L is equals to 2 meter. Okay, so the length of the pendulum is equals to 2 meter, right? So let's go to the board to pick the answer to this question, which is option C, 2.0 meter, meaning the original length of the pendulum is equals to 2.0 meter. Question 38. A sonometer wire is vibrating at frequency F0 if the tension in the wire is doubled while the length and the mass per unit length are kept constant. The new frequency of vibration is, so since the length and the mass per unit length are kept constant, then the frequency of vibration of a sonometer wire is directly proportional to square of the tension. Okay, so F0 is directly proportional to the square root of the tension. Okay, so that F0 is equals to K root T, right? So this is the original tension, so let's call it T0, right? Now this is the new frequency, and the new frequency is what we are looking for, while the new tension, let's call it T1, but we are told that it was double of the original, so let's call it T0, right? Now if we make it the subject of formula, we'll be having F0 over root T0, right? So this will also be equal to the second one, so that F0 over root T0 is equals to F1 all over root 2T0. Okay, now since we are looking for the new frequency, okay, so since we are looking for the new frequency, in this case we are going to make the new frequency the subject of formula, so that if we cross multiply, we'll be having F1 times root T0 will be equals to F0 times, okay, root 2T0. Okay, so since we are looking for F1, right, we divide both sides by root T0, so that F1 is equals to F0 then times root 2T0 all over root T0, right? So we can spread this out according to the laws of logarithm, so that F0 times root 2 times root T0 over root T0. So these two will cancel out, so that F1 will be equals to F0 root 2. Okay, so this is the value of the new frequency. So let's return back to the screen to pick the correct answer to this question. Okay, the new frequency of vibration is F0 times root 2, and that agrees with option D, F0 times root 2. Question 39. A traveling wave moving from left to right has amplitude of 0.15 meter, a frequency of 550 Hz, and a wavelength of 0.01 meters. The equation describing the wave is, so let's move to the board to solve this. So for the equation of a progressive wave, there are many equations. So the one you choose will be based on the option that is given to you. So based on the option that is given to us, so this is the most suitable one that we are going to use. Okay, 2 pi divided by lambda, then x minus vt. Okay, so if you check very well, so we don't know the value of v, so we have to look for the value of v. But remember that v is equals to f lambda. So I think that's why these values were given to us. Okay, so let's get our v first. So v is equals to 0.01 times 550. Okay, and that will be equals to 5.5 meter per second. Okay, so now that I've gotten the value of the velocity, then next we just substitute. So y is equals to, now remember a stands for our amplitude, and amplitude is equals to 0.15. So we write 0.15 here. Then sine, this is 2 pi, then divided by the lambda, which is 0.01, which is our wavelength anyway. Then your x minus the value of v, which is 5.5 t, right? Now 2 divided by 0.01, I think that should be equals to 200, so that our y is equals to 0.15 sine 200 pi, okay, then bracket open, x minus 5.5 t. Okay, so this is the equation describing the wave. Okay, so let's move to the screen to pick the correct option to this question. Okay, so from our calculation, the one that agrees with what we have on the board is option A, which is the wave is described by y is equals to 0.15 sine 200 pi bracket open x minus 5.5t bracket close. So that makes option A the correct answer to this question. Question 40. A transverse wave is applied to a spring whose mass per unit length is 3 times 10 raised to power minus 2 kilogram per meter. If the spring is under a tension 12 Newton, the speed of the propagation of the wave is, so let's move to the board to solve this question. So the speed of propagation of the wave is given as V is equals to root T over M. Okay, where T stands for tension and M stands for mass per unit length. Okay, so V will be equals to root tension is 12 divided by the mass per unit length, which is 3 times 10 raised to power minus 2, right? So if we divide, that will be equals to 4, so that will be having root 400, right? So if we divide, this is just simply divided here by 3 and divide here by 3, that gives us 4, right? Since this is raised to power minus 10 and this is times 10 raised to power 0, so if I move this up, in that case it will change to plus, so that will be having 4 times 10 raised to power 2, and that will be equals to 400. Okay, so the square root of 400 is equals to 20. So in that case, the velocity of propagation of the wave is equals to 20 meter per second. Okay, so let's return back to the screen to pick the answer to this question. So our answer is 20 meter per second, and that makes option B the correct answer to this question. Question 41. An engineer intends to deviate the light ray from its path by 120 degrees through reflection from a plane mirror. Calculate the angle of incidence. Okay, so let's move to the board to provide answer to this question. So to solve this question, it's important that we make a little sketch of the plane mirror. So this is the plane mirror, and this is the incident ray, okay, and this is the normal, and this is the reflected ray, okay, arrow, right? So according to the question, we are told that the engineer intends to deviate a light ray from its path by 120 degrees through reflection from a plane mirror. Okay, so from here to here, let's assume that these are our 120, okay, these are 120 degrees. Okay, so that means the angle of deviation has been given to us to be equal to 120 degrees. So you can see all the angles are on a straight line. Okay, and remember the angle on a straight line is equals to 180. So here we just say the deviation plus the angle of incidence plus the angle of refraction is equals to 180. But remember the second law of reflection, okay, that angle of incidence is equals to the angle of reflection. So in place of arrow here, we are going to replace it with I. So that, but our D was given to us because 120 degrees. So let's just put it here, and here will be, so if we add these two together, in that case it becomes 2I. It's equals to 180. So we collect like terms, so that 2I is equals to 180 minus 120, and that will be equals to 60, right? So we divide both sides by 2 because we are looking for angle of incidence. So in that case, I is equals to 60 divided by 2, okay, and that will be equals to 30 degrees. Okay, so remember that our I here represents angle of incidence. So let's return back to the screen to pick the correct answer to this question. Okay, and that will be option C, 30 degrees. So the angle of incidence is equals to 30 degrees, option C. Question 42. The diagram above shows a maximum and minimum thermometer divided into 3 portions, P, Q, and R. Which of the following is true about the respective content of P, Q, and R? So basically, this is 6 maximum and minimum thermometer, okay, inverted by James 6. Okay, for the 6 minimum and maximum thermometer, there are only 2 liquids used in it, and that is alcohol and mercury. Okay, so this part is filled with alcohol, while the U-tube here is filled with mercury, while this other part is also filled with alcohol. Okay, and this part is the minimum side, which is used to take the minimum temperature, and this other side is the maximum side, which is used to take the maximum temperature. Okay, so after taking maximum temperature or minimum temperature, the thermometer can be reset by using a magnet. Okay, so What the liquid that we have in this P part here is alcohol, while on the U-tube or the U-tube part here, which is the Q part, we have mercury, while on the arrow part here, we also have alcohol. Okay, so let's look option A. Option A, we have alcohol, mercury, and alcohol, which agrees with our explanation. Then B, we have air, alcohol, and mercury. There is no air. It only uses two liquids, which is alcohol and mercury. Okay, then option C, we have mercury, alcohol, and mercury. No, it's not mercury, alcohol, and mercury. Then option D, we have air, mercury, and alcohol. No air at all. Okay, so that makes option A the correct answer to this question: alcohol, mercury, and alcohol. Question 43. The diagram above shows two capacitors P and Q of capacitance 5 microfarad and 10 microfarad. Find the charges stored in P and Q respectively. So let's move to the board to provide answer to this question. Okay, so the relationship between quantity of charge and the capacitance of a capacitor and voltage is given as Q is equals to CV. Okay, so in this question we are asked to calculate the charges stored in each of the capacitor, which is P and Q. Okay, so for P, the capacitance is equals to 5 microfarad, while for Q, the capacitance is 10 microfarad. So using this relationship, we can calculate the quantity of charge in each of the capacitance. Now remember, in the question, in the diagram, V was given to us to be equals to 20 volts. So to calculate for the quantity of charge in the P capacitor, this will be equals to 5, okay, then times the voltage, and that will be equals to 100 microcoulombs, okay, while for the Q capacitor, okay, we'll be having 10 times 20, and that will be equals to 200 microcoulomb. Okay, let's return back to the screen to pick the correct answer to this question. Okay, so from our calculation, we got the quantity of charge in the P capacitor to be equals to 100 microcoulomb, and for the Q capacitance to be equals to 200 microcoulomb. Okay, and that agrees with option C, 100 microcoulombs and 200 microcoulombs. Question 44. In the diagram above, a beam of white light travels from a rare to a dense medium. What colors of light do the rays A, B, and C respectively represent? So this is a question on dispersion of white light. Okay, so dispersion of white light is simply the separation of white light into its component color. So when a beam of light passes from a rare to a dense medium, the white light will be separated into its component color. So normally we have this acronym that we use to remember the colors that will be produced, which is ROGBOOF. Okay, so remember this. This is arranged according to decreasing wavelength. Okay, so those colors with shorter wavelength will bend more than those with longer wavelength. Okay, so and this is decreasing wavelength. What that means is that the color red here has a higher wavelength, or it has the highest wavelength among all the colors here, and violet here has the least wavelength. Okay, so this color red will bend less because of its long wavelength. Okay, while the other colors will bend more than the color red. So let's look at what is given to us here. So, and we also look at the options. So we are giving A, we are giving B, we are giving C, and the options that are given to us here, I think we have just only 4 colors, which is red, green, blue, and yellow, right? So what does A represent here? So because A has the highest wavelength, it's going to bend less. Okay, and this is with respect to the normal. Now remember, this is the normal. So this is with respect to the normal. What that means is that C actually bent more than A. Okay, so the A here represents red, while the B represents green, while the C represents blue. Okay, and this is in accordance with the mnemonic that used to represent the colors. Okay, when white light is separated into its component colors, right? So A represents red, while G here represent, which is B represent green, while C represent blue color. So that makes option A the correct answer to this question, and this is in accordance with the wavelength of the different colors. Red has the highest wavelength, take note, and violet has the least wavelength. So those with those with higher or longer wavelength will bend less, okay, as they pass through, as they come out through the dense medium, while those that have the shortest will bend more, and that is why C represents the color blue. Okay, so that makes option A the correct answer to this question. Do you have any question to ask? If yes, you can do that by simply clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution providers will provide answer to all your questions within a short period of time. Moving on to question 45. In the diagram above, the values of V1 and V2 are respectively. So let's move to the board to provide answer to this question. So first of all, we have to calculate for the effective resistance. Okay, so the effective resistance is equals to, so it's the summation of all the resistors that are all the resistance that are given to us there, which is 3. Okay, which is 3 plus 2 plus 1, which is equals to 6 ohms. Okay, and the reason for that is because remember that current is equals to E all over arrow plus small arrow. Now the small arrow here stands for internal resistance, while the big arrow stands for external resistance. So if we add everything together, okay, that will give us 6 ohms, which is exactly what I'm showing here. Okay, so current will be equals to, now our EMF in this question is given to us to be equals to 2 volts. So that we'll be having 2 over 6, right? So if we divide this, we'll be having 1 over 3 ampere as the current. So in this question, we are expected to calculate the values of V1 and V2, okay, in the diagram above, right? Now remember that according to Ohm's law, V is equals to IR, right? So we already know our I to be equals to this, and we know each of the values of the resistor. So for V1, okay, the value of V1 will be equals to IR. Okay, let's just write the IR, and that will be equals to V1 is equals to 1 over 3 times the value of the resistor there, which is 3. So 3 we cancel out 3, so that we'll be having 1 volt. Okay, so I'll be having 1 volt. Right, for the V2 we'll be having the same thing, I times arrow. Okay, and that will be equals to V2 will be equals to 1 over 3 times 2. So in that case we're having 2 over 3 volts, right? So the value of V1 is 1 volt, while the value of V2 is equals to 2 over 3 volts. So let's return back to the screen to pick the correct answer to this question. Okay, so option D agrees that the value for V1 is equals to 1 volt and the value for V2 is equals to 2 over 3 volts. Do you have better explanation or solution to any of this question? You can simply do that by going to the comment section below to comment the question number and the solution you wish to share. Question 46. The correct position for a fuse in the diagram above is A between P and Q, B, Q, C, S, and D, P. Okay, so first of all, fuse is a device that someone acts as protector to electrical devices in case of over voltage, okay, over high current or voltages that usually spoil electronics. So instead of destroying the electronics, it will destroy the fuse, thereby protecting the devices. Okay, so the correct position for the fuse according to this diagram will be at the point P. Okay, because at the point P we have live wire there. Okay, that means there is current there, right? While the neutral, the position Q means there is no current, so there's nothing to destroy the device. Why? This is just Earth. Okay, so the correct position for a fuse in the diagram above is at the point P, and that makes option D the correct answer to this question. Question 47. If current flows in the direction of the arrows in the solenoid above, the north pole is a dash. So a solenoid is a conductor carrying current, okay, a current carrying conductor, right? So for us to determine the direction of the north pole for the solenoid above, there are two methods that we can use. So we can either use a magnet, if it's a live solenoid, right? We can either use a magnet, we just bring a magnet, maybe the north pole, and bring it close to the part labeled Q, right? So if we bring a north pole of a magnet close to this and there's repulsion, then we just know that the part Q, or the point Q, is south pole of the solenoid. But if we bring a south pole of a magnet close to it and there's attraction, we just know that this part is the north. Okay, but this is not a live solenoid. Okay, so we can use the right hand rule. Okay, we can use the right hand grip rule to determine the direction of the North Pole. Or we can as well just look at the direction of flow of the current. So if the direction of flow of the current is anti-clockwise, then we just know that it is the North Pole. But if it is clockwise, then we just know that it is the South Pole. Looking at this diagram carefully, we find out that the direction of current is actually anti-clockwise. Okay, so that makes Q the North Pole. Okay, so the answer to this question is option D, Q, the North Pole. Question 48. In the AC circuit above, the current value is, so let's move back to the boards to provide answer to that question. So first of all, in that question, we are given resistors or resistance to be equals to 30 ohms, and we are given the reactance, okay, to be equals to 40 ohms also. Okay, so we can calculate for the impedance first. Okay, so the impedance is square root of r square plus s square. Okay, so Z will be equals to 30 square plus 40 square, and that will be equals to 900 plus 1600. So if we add these two together, that will be equals to, this will be equals to 2500. So the square root of 2500 is equals to 50 ohms. Okay, equals to 50 ohms. Right, but in this question we are asked to calculate for current, and current I is equals to V all over Z. Okay, so in this question the voltage is equals to 200 volts, right? So we put 200 here, then divided by our impedance, which is 50. So 200 divided by 50, that will be equals to 4. Okay, 4 amperes. So the current is equals to 4 amperes. So let's return back to the screen to pick the correct answer to this question, and that is option C, 4.00 ampere. Question 49. A handbag containing some load weighing 162 Newton is carried by 2 students, each holding the handle of the bag next to him. If each handle is pulled 60 degrees to the vertical, find the force on each student's arm. So let's move to the board to solve this question. So to solve this question, drawing diagram is necessary. So let's say this is the bag and it has a weight of 162 Newton, right? These are the 2 handles held by those students, okay? And the handle makes an angle of 60 degrees to the vertical, okay? So we have to resolve each of these into the vertical component. So we have to resolve the force into the vertical component. So that T, let's call it T, tension on both arms, so that T is equals to F cos 60 degrees, and here is also F cos 60 degrees. So there are 2 forces acting vertically upward, and there's one acting vertically downward. Okay, so the force acting vertically upward is equals to the one acting vertically downward. So the 2 tension, which is T plus T, which is 2T, will be equals to 162, right? But T is equals to F cos 60, right? So that will be having 2 times F cos 60, which is equals to 162. Okay, so now we're looking for F, which is the force on each student's arm. So that, but remember that cos 60 degrees is equals to 0.5. So 2 times F 0 times 0.5 will be equals to 162. So that 2 times 0.5 will be equals to 1. So that F is equals to 162 Newton. So the force on each student's arm is equals to 162 Newton. So let's return back to the board to pick the correct answer to this question, which is option C, 162 Newton. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video.